Today we will study the case of source moving away from the observer. Yesterday we have studied source moving towards the observer. That time we found that when the source moves towards the observer, f prime equals to v upon v minus us into f. While source moving towards the observer, there is v minus us. Just speculation, you can guess it. Today our result may come v plus us. यो वेभ्सको नम्बर त्यति नै छ, डिस्टेन्स चाहिँ बढ्यो भनेपछि एउटा वेभले अकुपाई गर्ने डिस्टेन्स चाहिँ बढ्यो हैन। वेभलेन्थ भनेको त एउटा वेभको डिस्टेन्स हो, ठीक है। Suppose the source s moves away from the observer with velocity us. In this case, f waves spread in v plus us distance as shown in the figure. Then the increase in wavelength is lambda prime equals to distance upon number of waves. What? Distance upon number of waves. And the next is the apparent frequency. The velocity of the wave relative to the observer is v, because the observer is at rest, so the relative velocity does not change. We are talking here the relative velocity of the wave with respect to the observer. If the observer is not moving, the relative velocity does not change. Change in the velocity of the source does not change the relative velocity of the wave. This is the common formula that we have written yesterday. F prime equal to velocity of the wave relative to O upon apparent wavelength. And velocity of the wave relative to O is v, and apparent wavelength is v plus us upon f. Simplify it. F prime equals to v upon v plus us into f. I would like to explain this also. V plus us is greater than v. Do you agree with this?
Yes.
Because there is something is added in the v here, and there is only v. This time it is greater and it is lower. In order to be the product equal, if v plus us is higher, f prime should be lower. Okay? If v is lower, f prime should be higher. Okay? So f is higher and f prime is lower. Now we can say that f prime is smaller than f. There is positive relation. When source comes towards the observer, frequency increases. Coming towards is the positive thing, going away is the negative thing, yes? So when source moves towards, frequency increases. When source moves away, frequency decreases. Very simple, okay? Okay? And thus apparent frequency decreases when the source moves away from the observer. Number 1 was source in motion. Today number 2, and its first case. What? First case, okay? And we got it. That is source moving towards the observer, observer moving. In this case, right here source, right here observer, okay? And observer moving towards the source is here. Do you agree with this? And let's give its velocity u. U means velocity, O means observer velocity. And in this case, waves do not, in this case, neither the waves compress nor spread. Our source. This is our case. In this case, wavelength does not change. What happened?
Does not change.
Because there is no change in the distance. Why? In this case, wavelength does not change. So lambda prime is equals to, lambda prime is equals to lambda equals to only d by f. apparent wavelength is the same as the real wavelength and that is v by f. यहाँ किन wavelength change गर्नु भने यहाँ यो फिगरमा f waves ले कति डिस्टेन्स कभर गर्छन् only v distance. Okay, how much? V distance. F waves cover v distance. And lambda equals to v by f, it does not change, and our main thing is coming. The wave is moving with this direction with velocity v. What? V. Okay? And the observer is moving from this direction towards this. Wave is going with velocity v. Observer is moving towards the wave with velocity u. These are the case of opposite direction. What?
Opposite direction.
In opposite direction, relative velocity is obtained by adding v plus u. Do you remember this?
Yes.
In the same direction, to find the relative velocity, you have to subtract. In opposite direction, you have to add. So, relative velocity of the wave, this one is the different one only. Okay, velocity of the wave relative to the observer is v plus u. F prime is the apparent frequency, velocity of the wave relative to the observer upon apparent wavelength. Our apparent wavelength is how much? That is v plus u. But the logic is that it is per O is per observer, it is not the zero. And the final relation here, say the final relation, F prime equals to
V plus
v plus u upon v into f. V plus u is greater than v. F prime is greater than f. I think at this time you will directly understand from here. V plus u is greater, okay? So f must be lower. It means f is decreased, means f prime is increased. You got it. In this way we go on, keep on repeating the things. To find other cases also. The wavelength does not change. Okay. When the source moves, wavelength changed. You can memorize this thing also. When source moves, that time wavelength changes. When source does not move, wavelength does not change. In this case, relative velocity is changed. To make the statement sweet, you can write over here like this way. Okay. Now the source, suppose the observer is moving towards the source with velocity u. In this case, right? Listen. In this case, wavelength does not change, but relative velocity change. What change? Relative velocity change. Velocity changes. How complicated? This is explained right now.